Today we're going to look at Lesson 5, Geometric Series. So what a series is when we're looking to find the sum in a sequence. So let's say I had a sequence, 2, 5, 8, 11, and I wanted to know, a sub 5. Right? A sub 5 would mean, okay, this pattern that's adding by 3, where I have a common difference of 3, the next term would be 14. But if I wanted to know S sub, let's say, 5, what I'm looking to do is to take the first 5 terms and add them up. So if I found that sum, let's see, so if I added up 2 and 5, that would be 7 and 8 and 11 and 14. I would get 40. So in this course, we don't actually concentrate on arithmetic series, adding up the terms of an arithmetic sequence, but that is what a series is, when the goal is to find the sum of a certain amount of terms in a sequence. And we're going to put our focus on geometric patterns. So if I were to give you, a similar, let's say I multiply by 3, so 2 and then 6 and then 18, right? If I said to find the, let's just say, third sum, so I just want to take 2 plus 6 plus 18 of this sequence, I would get 26. Just like with the arithmetic one above, I could just add up the terms. But there's a formula when we're dealing with a geometric sequence series that we can use, and it's on your reference sheet. So this formula down here, if I plugged in my sequence from above, which is, I was finding the third term of that geometric sequence, 2, 6, 18. This formula works by taking the first term, which up here I had an A1 of 2. Then you subtract from that A1 again, but times R. So in my sequence, I was multiplying by 3. So R is 3. So times 3 to the n. N would be how many terms do you want to find the sum of? So in my little example above, I was finding the sum of just those first 3 terms. And then you divide by 1 minus R. So obviously, looking at this from above, I was able to just add 2 plus 6 plus 18. But if I wanted to plug into this formula, and if you take a moment right now to plug in what I have here, the 2 minus 2 times 3 to the third over 1 minus 3, you will also get 26. So in order to use this formula, we need to know a couple of things. We need to know what the first term is, right? So that's in the formula twice. We need to know what the common ratio is. That's in the formula also twice. And then we need to identify, well, how many terms are we trying to find the sum of? And again, note the notation. You're going to see an S with that subscript of n, and that's going to know that you want to try to find the series as opposed to a term in the sequence. Okay. So now that we kind of have an idea of what a series is asking us to do, find the sum of the terms in a sequence, I want you to pause the video and just take a look at number 1 and see if you can use the formula from above to answer the question. Okay, hopefully you've had a chance to read it over and try it yourself. This is talking about someone that wants to buy a car and is trying to save $5,000 for a down payment. The table below summarizes the amount of money that he plans to save each week. So week 1, he's going to save $2. Week 2, he's going to save $5. Week 3, $12.50, and so on. So if I want to figure out the pattern here, I could be thinking, oh, maybe it's add 3, but then that goes away right away as soon as I see 5 and then 12.5. I'm not adding 3. So if we want to see what the common ratio might be, we would take 5 divided by 2, or 12.5 and divide it by 5. And if I do that, 12.5 divided by 5, 5 divided by 2, either way, you're going to get 2.5. And that's going to be consistent even if you took 31.25 and divided it by 12.5. Okay, so we have this geometric sequence with a common ratio of 2.5, so that's what we're multiplying by to get from term to term. I can see that my first term, so here, let's highlight a few things. So that's my R, right? Then my first term is 2, because in week 1, that's how much money we're saving. And they want to know, well, how much money did they save then in N weeks? So we're not actually finding a total amount. We're just trying to find the correct formula. So S sub N would equal first term minus first term times R, which is the 2.5, to the N power over 1 minus 2.5. And if you look for this in our choices, you should get choice 1. So this would be the formula that if we said, okay, now let's maybe see how much have they saved in 10 weeks. You could plug in a 10 and it would give you the sum of those 10 weeks of savings. Okay. Now I'd like you to, again, pause the video. I'm going to write the formula down here so that if you're not looking right at it, you have it. And then take a look at number 2. Okay, so try to stick with my colors here. So first term, so Alexa earns $33,000 in her first year teaching. And then it says that her amount is going to increase by 4% each successive year. So this is going to help me figure out my common ratio. But what we want to remember here is when you increase by a percent, we have to think about how do we build that. So it's not just going to be multiplied by 4% or 0.04, right? How do we show the increase of that? We take the rate, which is this, and we're going to add it to 1. So 1 plus 0.04 or 1.04. This would be our common ratio. Right, so the rate is really helping us get the number that we're multiplying by. And then they ask us just to write a formula that represents her total earnings over N years. So similar to the one above, we just want to kind of write a formula that would help us. They tell us to use S sub N. So S sub N would equal her first year's salary, that first term, minus that first term, times 1.04 to the N over 1 minus 1.04. Right, so if you were thinking, if you're having trouble right now identifying like why is it 1.04, because I feel like sometimes that's the hardest part. If you thought about her first year teaching, right, as a sequence, and then you wanted to know, well, what is she going to make the second year, right? If you just took 33,000 and multiplied it by 0.04, right, it's going to give you 1,000. So if you took 33,000 and you multiplied it by just the increase, you get 1,320. Well, that's not how much money she's making in her second year of teaching. That's her raise. So if you take 33,000 and you multiply it by 1 plus that rate, right, you're going to get that amount added on to the 33,000, which would be the 34,320. So the number we're multiplying by is that increasing rate of 4% added to 1 so that we get the next year's income. Okay, then it goes on to say, now use this formula to find her total earnings for her first 15 years of teaching to the nearest cent. So nearest cent, remember that's hundredth, 2 decimal places, hundredth. And now we're just going to plug in. So S sub 15 equals 33,000 minus 33,000 times 1.04 to the 15 over 1 minus 1.04. Okay, so if we plug into that formula, you should get 660,778.392, and then just make sure you round to the nearest cent. so 0.39. And just one thing to mention about this question on the regents, I don't think it was separated into two parts. It was like this part was all like at the end of this, right? It was like one paragraph. And the thing is, if you didn't write this part here in terms of n, if you just went right to plugging in the 15, and even if you had the right formula, you plugged in the 15, you got the right final answer, if you never wrote the formula actually in terms of n, you lost a point. So just making sure that if they ask you to write something, right, like write a function that represents this, or write this geometric series formula, they're even telling you exactly what kind of formula. If you go to your reference sheet, that's exactly what it's called, geometric series. But you had to write it before you plugged into it. Okay. And then I want to talk about here in this lesson another way that we can calculate the sum of the terms in any sequence is something called sigma notation. So sigma notation, the word sigma just means sum. And if we ever wanted to evaluate a sum using sigma, we first need to understand what this even is. So I'm just going to grab my calculator. Okay, just to show you, in your calculator, sigma is in the menu alpha window, choice 2. So in case you ever had to go and type it in. Mostly with sigma in this course, you just have to know how to evaluate it because it sometimes is in the choices. But it's also a nice valid way, another way to calculate a series if they don't tell you you have to use the series formula. Okay, so sigma has basically 3 parts to it. You're given a value on the bottom of the sigma. This is going to tell you what number to start at, what number you're going to plug into some formula to the right. Then it gives you some number above it, and that's the last number you're going to plug in. So if you saw a 1 on the bottom and let's say a 3 on the top, it's telling you to add the first 3 terms. Plug in a 1, then you plug in a 2, then you plug in a 3. It's always substituting consecutive integers from the bottom to the top into whatever is to the right of sigma. So to the right is some formula. Right, so you can see here that's our geometric sequence formula. So let's go back to my example from earlier, my 2, my 6, my 18. Right, so if I were just looking at sigma and I needed to like find the sum, let's say, of those first 3 terms, I would see a 1 down here, then a 3 up here, and then over here would be the formula for this sequence. So that would be something I'd have to remember how to do. So 2 times 3 to the n minus 1, right? Because that's this formula. If I take my geometric sequence formula, we know that r is 3 and a1 is 2. That's my explicit formula for this sequence. So if I go and plug into this, all right, so in the calculator, we would just use x, right? We already know the answer to this because we've added these 3 terms before. We got 26. But this is just another way to get that sum. Tell your calculator, here's my formula for the sequence. Please take the number 1 all the way up to the number 3, plug them in, 1, 2, 3, and then add them up. And it does it for you all at once. So it's like plugging in the 1, right? Then it's adding to that a plug-in of the 2, and then it's adding to that the plug-in of the 3. So this is ultimately what your calculator is doing. It's plugging in the 1, then the 2, then the 3, and then adding them all up. Okay, so let's take a look at this last question. I want you to look at it, pause the video, and see if you can just make sense of which choice models this sigma or this sum. Okay, so Kristen wants to increase her running endurance. A gradual mileage increase of 10% per week can reduce the risk of injury. If she runs 8 miles in week 1, so right away I'm just going to kind of write down that's my A1. which expression can help her find the total number of miles she will have run over the course of her 6-week training program. So if you notice, they all have a 6 on the top because they're trying to find the sum if she starts in the first week and goes to the 6th week. So they kind of all make sense for that. If she's increasing her mileage run by 10% per week, that means the common ratio, 1 plus that rate, would be 1 plus 0.10 or 1.10. So if I look for this, right, so I'm going to have a sigma that has the formula to the right. So A1 times R to the n minus 1. And then we're going to start with week 1 and go out to week 6. I see this correctly written in choice 1. So they didn't actually ask you to find the sum of her mileage run, just what would make sense for this 6-week training program. And also, if you're ever typing in a formula into the calculator with sigma, just make sure you never write outside of the sigma parentheses, that you always keep everything written inside, otherwise it won't calculate it correctly. Okay, so there is practice for today's lesson, and we're going to practice more of this lesson tomorrow, so the homework will not be due tomorrow. So just, give the practice a try, and we'll continue on with this a bit more tomorrow.